Oh, the window is the wrong size, but let's not third time's the charm. There we go. Okay, so welcome back to Crafting a Crawler, week 12, 12 weeks of game dev so far. And this week we are continuing off where we left last week, and we were looking at the different kinds of procedural generation, the different algorithms and things that we could make use of. And this week we're going to continue to look at some more of those. So we're back in our notebook. I did make some changes to this, tidied a few bits up after the last stream, and I made things a little bit more composable so that we could sort of plug the algorithms into each other. And then this week, so I'll go over what we have as well as a bit of a reminder, because I haven't looked at this since last week either. So yeah, we're using a maths library to plot our maps, but we're not really using any special sort of math stuff. Tools in Python to generate them. I want to keep it as straightforward as possible, so that when we come to porting it back to Lua, and potentially if anyone else is looking at this and want to port it to other languages, then they'll have an easier job. But yeah, we've got some constants we've defined, so the width and the height of our map. So all of them we're looking at sort of 200 by 200 tile map. And at the moment we're only defining air and wall tiles. We've got a few types we've defined, such as our map, which is a two-dimensional list of integers. So we've got our y list, and for each y coordinate we have an x list of integers. We've got basic rectangle type, which is the x, y, width and height. We defined some protocols for our generators. Actually, let's give all of this a run as well first, so it can run in the background while we scroll down. So this is a function. Our generators are all functions, and they take some input. They take the map data, an x and y coordinate to draw from, a width and a height, and a random number generator. We have room generators. These can generate a set of rooms within our map. These take x, y, width, height, random number generator, and return a list of rectangles. We have edge generators. So yeah, this is all stuff I think I did after last stream when I was breaking down the room-based generator. So we also have edge generators. An edge generator will take a list of rooms and the random number generator, and it will generate a list of edges between those. So between the indexes of the rooms within the room list, it will generate a thing, i.e. 0 to 1 will be a connection between the room in index 0 and the room in index 1 of our array. We have tunnel generators. These will dig out a sort of tunnel or corridor between two rooms. So we give it 2x and 2y, so two x and y coordinates, and it will dig out the route. And then we have some methods here for rendering out our room. A few helpers. We've got a draw method that will draw a sort of box of a set size centered on our x and y position. We have a method to get the neighboring tiles, and how many of the neighboring tiles match the value we pass in. Method finding center of a rectangle, and then we have a little helper here for running a bunch of generators one after the other. So this creates a new generator that will basically run each generator in turn on our map. And then we have another method for finding the number of tiles that match a specific value within a region of the map. And yeah, so that's our basic helpers and stuff there. Not expecting anyone to be fully up to fully grab that yet, but as we start to look at the individual generators, hopefully it will start to click. So our first is the most simple of the generators, and this is just to pick tiles at random based on the ratio. So if we say a ratio of 50% of the tiles by default should be air, and then we set the value of the kind of tile, and then we'll just go over each tile in order, and we'll set it to either we'll set it to air based on whether or not effectively on a roll of the dice with a chance of equal to the ratio, and then we'll set it to our value. And this gives us a nice sort of static-y sort of output. It's not much use as it is, but we use it's useful as an input to other some of our other generators. Maybe we're actually zoomed in a little bit too much here. Can't actually see these fully. Well, yeah, if we zoom out, we can't really see the text very well either. Yeah, the other one is similar to that, where we pick points at random, and that gives us pretty much the same result. If we're using a very low percentage, then this would be possibly a bit more efficient. And this will actually also take into account the percentage that's already set. We could probably update this to be similar actually, but we're going to get a very bad distribution then, so it'll only be the top and then the rest will end up black. We have a simplex noise-based one. This generates some interesting patterns, but because it's based on X and Y, and it maps across the whole of the space, we don't necessarily get a connected sort of space. We've got all these little bits that are sort of cut off. Next, we had our top performer, which is the drunkard walk, in which we effectively just keep spawning drunks in the middle of the map and let them wander off in random directions, staggering around, and as they do that, we carve out part of the map to match. And then so this gave us some interesting looking sort of designs based on how many steps we allowed them to take before they passed out, what percentage of the map we allowed them to explore, and so on. We got some sort of interesting sort of shapes. Out of this. We have a couple of other sort of generators here that aren't too useful in and of themselves, but they sort of operate as a good sort of thing to help with post-processing. So one is a frame, so we can sort of frame out another generator. So here we have our random choice one, and then we put a frame around it, and we can say so many. So we can say two tiles on each of the edge should be a wall. We have filled, which just fills the whole space with a single tile. And as I said, these aren't very useful in and of themselves, but they work useful as inputs to some of the composite generators. And what I started to look at was how we could break down what we had last week into pieces so we can chain them together and get more interesting results. So one of those, for instance, is cellular automata. Cellular automata. So this is like Conway's game of life, and with our change it, I think last week the way we left it, we were passing in a generator to use as a base, but now we can sort of chain them one after the other. So we can sort of start with a random map of 45% walls, put a frame around that so that we've got two tiles on each edge are also walls, and then we can run cellular automata in there. And for any tile where 4 of the sort of local neighborhood of 3x3 sort of 9 tile neighborhood is a wall or an air block, then depending on how we set it up, then that becomes a new air block. And if only 3 of them are, then it sort of dies and becomes a wall. So we can run that on the random, and then we can also run it on the random walk as well. So that gives us pretty interesting results. The cellular automata gives us a nice sort of interesting cavey sort of shape. We can play around with the values on that. So if we increase the number of walls, no, I think that increased the number of air actually. So we can set that to 4. We'll get more of the areas filled in. Which actually I think that's probably a nicer thing. The only downside of cellular automata on a random map is we are not necessarily guaranteed that every area is sort of accessible. But what we did find is that when we apply it to things like a random walk, it will smooth out the random walk. So like this is the base generation without the cellular automata applied. And then when we run cellular automata on that, we get sort of more. So these areas are a bit more neatened up, whereas here they're a bit more jagged. And then there's this one down here. So they end up a bit more round, and then we get smoother sort of walls. Gives us a nicer look to things. And that was all based on just generating at random on the map. We then have our room-based generator. So I broke down the room-based generators a bunch, created a generic room-based generator. And this will take a room generator, an edge generator, a tunnel generator, and a generator for the space. And this is where, for instance, we'll default the inner one, the generator for the rooms themselves to our fill one. So this will just fill it out as a rectangle of air. And then we could play with some of the functions, and then we generate the edges. We can either use a naive approach, in which case we just connect each room to the previous one in our list in order. This works quite well for some styles of generator, but not for others. And then we have like a sorted one where we can sort everything by its x coordinate. That just seemed to give us a bit more sensible connections for the random ones, room placement. And then we've got a simple tunnel generator that will dig out L-shaped tunnels based on the it will dig out an L-shaped tunnel between the rooms. So it'll go along in one direction up, or it'll go down and then across, sort of thing, to bury them out. So yeah, so our first attempt at a room-based one was just to pick random widths and heights. And keep doing that, see if they overlap, and if they don't, then we can add that to our list. So that gives us some interesting sort of shapes. And we can rerun. Oh, if I actually go in there, I can. And so this gives us, this is just picking spots at random for the rooms and then interconnecting them. So this gives us quite a, it's not a terrible approach, but we get a lot of sometimes it doesn't really make much sense. Next one we're looking at, which I don't think I fully got finished in the last episode, but I did. It was bugging me that I couldn't figure it out and didn't get it finished on stream, so I did give it a bit more time after, and I finally got it sort of working. By doing that, I sort of created a binary node, and this allows us to divide something into a left and a right side and keep dividing downwards until we keep dividing that downwards. And then we're able to recursively tie it back together into a single list. And then our generator here, we were looping over and looking at each sort of region, and then splitting and then putting a room within that. Then we kept going. We kept splitting it down until we had our regions, and then we loop over and put a room within each of those regions, and then that gives us that tends to give us a slightly more sensible layout. So we get a lot less sort of weirdness in the shapes. We get a bit more variation as well. Yeah, and then after all of that, I stitched a bunch of the generations together. And for instance, if we use the binary space partitioning, then instead of using a sort of empty space, just filling it with a rectangle, if we use the drunkard's walk within each room, and then connect that together, and then smooth the whole thing out with cellular automata, then we get far more interesting sort of patterns and shapes. So this one, for instance, is I think where one of the best results we've got so far. Yeah, so this generates some really interesting sort of patterns. At the moment, this is only generating on a few sizes. Sometimes it gets a bit, so it's sort of hitting the edge a lot there. You can see. Yeah, and then we can mess around with this a bit. So at the moment, it's using 40 by 40 as the minimum room size. If we decrease that down to 10, and then we've got 200 map. That's 20 rooms on each side. Sorry, it's 20 by 20 grid of rooms. It's up to 400 rooms, so we can maybe put 100 in there. So we want them a third filled. We generate that. Okay, that's a. What do we go for? Fourth? Slightly smaller tunnels. Yeah, I mean that's not a. We're getting some sort of more. I think probably need to decrease the distance the drunk can walk. So if we say they can only go 100, they're still butting up against the walls a bit. 40. Yeah, some of this is a lot more interesting in the shape of it. What if we actually take the walls, the spreading of the rooms out, so just rely on the randomness. Some of these are quite interesting. I mean, a bit when we improve the tunneling between the rooms as well, we'll get some more interesting sort of layouts and stuff. But yeah, this is what have we got up to? 50% might have been a bit too much for the length of the walk. Yeah, I mean, for trouble we have is for some of the bigger room. Actually, the problem we have here is that for some of the bigger rooms, the drunks can't quite walk far enough to reach the edge. So they can sort of carve out a middle section, and then they only get to the edge before they fall over. So they can't finish the room, which is an interesting problem. So we probably need to actually revisit our drunken walk and add some sort of maximum number of walkers. So that's not. Then we could also make this slightly more interesting. So we fill in some of this as well with we can vary the randomness up a bit. So we could then also fill in some of the open space with walls. That gives us a bunch more empty sort of spaces, unconnected spaces, but it's sort of the bits that, for the parts of the room that it does connect to, it sort of varies it up a bit more. What if we actually just apply this to the whole of the map? That's actually not too bad. If we went up to 5 there and then put like 2% of the space back as walls, what would we get then? That's probably too small of a staggering distance for our poor drunks there. It varies things up a little bit. But yeah, so this is the let's go back to 9, and I think we're at 40 by 40 for the room sizes. Oh, sorry about that. I'm still a bit under the weather from. I'm not 100% sure if I'm ill or if the hay fever is kicking in, but the antihistamines are definitely not doing their job yet. But yeah, okay, so this isn't too bad. So we need to frame it afterwards. We only need a one. one tile frame, but yeah, this it's creating some sort of interesting spaces. So I feel like once when these are sort of populated with places of interest and other things and biomes and stuff, and we'll get some sort of interesting sort of exploration here. Yeah, so going back to the start, we have a list of things that we wanted to look at. And I'm not sure we'll get through all of this today, but so there'll probably be a part 3 on this at some point. Yeah, so there's a few things we could look at with the we could look at. I think some of this I still need to go off and read some papers and stuff to wrap my head around the algorithms, but we could definitely start. Oh, I'm also looking very dark. There we go. Yeah, that's a bit better. Yeah, so one of the things that I want to try and look at is diffuse limited aggregation, because that is a sort of a Walker-based algorithm similar to the drunkard's walk. So that'd be interesting to look at. The Voronoi cells is another interesting one. So I'm not. It will potentially generate some interesting shapes, but this similar to our simplex noise algorithm base generator. I'm thinking will be more useful. The algorithm itself become more useful in generating biomes. Sorry. Wave function collapse, I definitely need to do more reading on. We could try and look at some maze generation algorithms. We could also look at some symmetry based stuff. So potentially as we draw, we can look at making rooms symmetrical and see how that what sort of outputs we get from that. Yeah, I think also I want to. So one of the things, another thing I want to look at as well is that we pass a lot of data around, and it's the same data. So x, y, width, height, random number generator goes into our room generator. It goes into our generator. We pass some of that information in here, but then in the tunnel generator we also have to infer some of the previous data as well. So what I'm thinking is that we could kind of create a context to hold a bunch of this. So let's define a context class. So we'll say it's something that contains information related to dungeon generation. We will we'll define this. We will have a data class. So let's make sure the Python data class library is imported. We'll make sure that is run. data classes are that's not what we're after. So this data classes are basically classes that contain pieces of data to them. So I think if we take our context, we can then redefine our generator to just take the context. Here. This will be our map context. Our room can also be the same, although maybe we want the do we want to store the rooms on the context? Let's leave it at this for now, and then we'll come back to it. So yeah, this can just be context. And again, we have our, which is the map context. We'll pass it into here as well. Take out the RNG one. We will also pass it into, potentially into the tunnel generator. As well. Because this kind of needs to know the width and the height of the whole map to draw on it, and at the moment it's sort of hacking its way into getting that value back. I guess for our renderer, here we'll generate our data, and then we'll go context is equal to that, and then we'll pass that into our generator. Some of these helpers can then move up to the context itself. So this draw method, for instance, has to sort of infer the size of the box that it's allowed to draw in. This kind of means that it can color over the edges a bit in some cases. So we can come back to our context and add this now. And instead of, so this can then become self. We no longer need to get the width and height anymore. Let's try and make this a bit more consistent with some of the other variables as well. So OX. And I think we've gone index X and or item X and item Y and some of the others, as well as these are not actually changing, and I think we were using NX and NY for new X and new Y for when we actually inferred something new. We go self.data. There, self.width, self.height. So that means we can now draw onto the context. We probably also want to divide to be able to generate a new context, like a subcontext. And yeah, for us, and this is going to be self, typing.self, so it returns itself. And this will mean that we can sort of define a position within the context. Ooh. Self.x plus so we can even offset some of this so that the drawing functions are offset by x and y as well. Okay, so that's going to give us a bit more of a smarter drawing function now, and we'll be able to get our subcontext. So then if we start looking at, we'll also need to look at our chain helper. Render helpers. So we can actually do away with this now. So let's delete those cells. The neighbors for can also go on to can also move to our context. Let's copy that. So yeah, we'll add this to the context as well. So this will then become self. We've got x, y, and the value. Don't need the width and height anymore. We've got x and y. Okay, so we've got self.x plus self.y. We've got the value. This needs to be between self.width and oh, actually, that's a problem for the drawer as well. So this will be self.x plus self.y and self.y plus self.height. And the same here, this will be self.x plus self.height and self.y and self.data. There we go. So that's now been adjusted so that when we look at things, we can use a local coordinate system. So 0 to width, 0 and 0 to height within our generators, and we don't have to worry about the where the sort of submap, the subregion is within things. Our context it knows that, so it can be a bit more aware than these helper functions used to be. So with that, we can also do away with these. The center for a rectangle will need to stay. This becomes context, and then we pass the context to each. to each function. Okay, so let's so given that all of these have executed successfully, okay, so now we can have a look at some of our generators. So we've got the random choice one. I think this becomes context, and it's for x in range of 0 to context.width. Here we go. We can, and we get out. One of the benefits here is we get our x's back, our x's and y's. So we kept having to find names that weren't colliding with x and y because we were passing those around. In fact, yeah, so in our generators now we can use x and y as normal. And then here we'll go for y in 0 to context.height. We'll look for a random value and we'll go context.draw x and y. Oh, sorry, context.draw x and y, and then the value will be the value for y. And if we give that a run, cool, so that's still working. Yeah, okay, so that's still working. So now we can come back and revisit our random placement one. So this is now going to take context instead. So we can actually, the count of, we can move into the context as well. So where was that defined? That was in center, chain, count of tiles. Yes, this could also go into our context. So count of so we have self. We don't need any of that. We just need the value. It's going to be for y in self.y to self.y plus self.height, and for x in self.x plus to self.x plus self.width. Give self.data for y and x is equal to the value. Then we have a value, and we add all those values up, and that'll give us the count of the tiles that match. So with that, we can now come back to our so we don't need this anymore. So this can go away. So we can abstract this total as well. So if we come back to our context again, we can set a size, and we'll return an int, and that will be the width times the height. So then in here we can go, so this will be context.size, and then context.count of the value. Yeah, so these are all getting far simpler now than they were previously. So given this, we will take a random int, interesting. Okay, so we even had a bug in this one because of after I'd updated them, this was still going from 0 to width, which would have not been what we wanted in some situations. So we can simplify this a bit more. I feel like this is a pattern we could probably need often. So we could even update our context to have a helper for that. No, and this will be between 0 and the width, minus 1, minus 1. Yeah, this will be between 0 and the width minus 1, and this will be between 0 and the height minus 1. Random point, I think, is a better name. So then in our random placement generator, we can then go x-y is equal to context dot random point. Then if we run this, oh, we have an error. Because we forgot to call that function. Oh. Sorry, I forgot to rerun it when I changed the thing. Okay, so this gives us a thing. What we can also do here, though, is we can now extend this a bit, I think. We could also add a size in. We'll set that to 1 so things stay the same. So now if we run this, we get a similar style output, but we can also then go for a larger scattering. Okay, so I mean that's already different. By increasing the size, we've ended up with a very different look. I'd be interested to see what cellular automata would do with with the output of this, where it's got some sort of more interesting regions. Yeah, okay, so that gives us, so we've already got a more versatile, we've already got more versatility just from updating, from centralizing some of our logic. We were able to see some small gains that we can make. So this, we were using a random value from the, we could attach the noise generator to yeah, I think this will keep as a random value, but we can also now make this a bit more simpler. So from X to context width, and for our Y will be 0 to context height. Go for I, sorry, for X and Y. And then we'll go context draw X, Y, and we'll draw it as air. And, oh, anyway, learn to spell, things will work a bit better. Okay. Let's have a look at our drunkard's walk. So I think we need to add a max so we'll set a maximum number of walkers for this generator as well. We'll add a context in, and this then becomes our the size. This is context and count of the value. So okay, yeah, this was the default values for the walker. So these will be just the width and the height divided by 2. And we'll go X and Y. We'll go context.draw. X and Y, we'll draw the value at the size. We'll generate a random integer between 0 and 3 for our direction, and then we update the X and the Y appropriately. These become simpler because it's context dot width -1. Yeah, or context dot height -1 for our X and Y. We decrease the steps, and then we set X and Y to the number. And we'll also set our walkers to 0. Every time we reset it, we'll go walkers is incremented by 1, and then if walkers is equal to max walkers, we'll put a greater than equal to just to be sure, then we'll break out of the loop here and there now. So this will mean that we don't get the continuously running forever if the number of walkers is bad. And then if we run this, yeah, we still get our drunkard's walk. What happens if we decrease this? How do these look actually if we decrease it to 2? I think we get slightly more interesting layouts because they get to wander around a bit more because they're filling up the space a lot less with each step. Yes, the longer walks, notice a pattern of they sort of meander off more, and then you get a much more concentrated sort of bit by the edge. Whereas the shorter walks, you get more interesting. You get a less sort of it pushes against the edge a lot less. So we could extend this in the future to have some sort of repelling force towards as it gets away from the center. So they spend less time sort of butting up into corners. We might get some more uniform shape, some more interesting shapes. So we were going to look at symmetry as well. So I think one thing we could do is when we define our context, after that, before that actually, let's define another type. So we're going to insert code, markdown before that. What is the indent on our headers for? And we'll call this brush. And this will be drawing parameters. For this, we'll define another data class. And this will have a size. Then in our draw method, maybe we'll have a value as well. So we define a value and a size, and then potentially here, then we specify the brush, brush.size, size again. And we'll define the value. Yeah, so with what I'm thinking is by doing this, we can then add some extra parameters into the brush later. So we can start to define maybe some symmetry. We could even look at some different shapes instead of just having the square brush. We could have a circular brush, for instance. So then if we look at the methods here, so yeah, then we can go, the brush is a brush, and then actually maybe that was not, maybe the brush should just define maybe the brush shouldn't define the value. So we'll come back to draw. We want to define X, Y, the value, and the brush. So yes, this will still be value. Yeah, this one will be a brush. We'll execute the ones above, so this is all set properly. This will be equal to, by default we'll have a brush we'll define a class method on our brush. Which will return a brush self. I think we'll define a size 2 brush. Actually, we can just define no, I guess we don't actually need a function for this. We can do it. We can just define new ones. But we will define a default brush, I think as a constant instead. Where's our brush? Here it is. So we'll go so we'll have a default brush, and this is what we'll use as the default into the parameters. So to run there we go. So then this, we'll set to default brush, give this a run, and we want to pass the brush through. define this one, and we get our chunky boy placement. Pass the default brush there. Here we'll have a default brush as well. Pass through. I think this is the Drunkard's Walk is I think where we will start to see the first application of if we add some symmetry into things. Oh, this is brush. I do wonder if the brush should contain the value actually. We do seem to be passing it together all of the time, so yes, I think we will do a value and if we define the default values, for each of these as 1 and air, then yeah, we want our draw. We're going to update our draw here, take the value out, and this becomes brush.value again. And then when we're defining things, so in theory we could what would we get if we actually defined a larger brush on our random here? Huh. Okay, so we get something similar but not quite the same as with the other generator. Yeah, I think this is where this sort of work is quite cool, and we get slightly different sort of things just emerging. As we look at the different sort of as we enhance this and we start to look at different bits, we get slightly more interesting outputs. And a lot of it, what we are going to do with generating stuff in our maps is going to be trying to find the interesting combinations of the various various generators, and chaining them together to get the more sort of interesting terrain generation. Yeah, so then we can just define our brush is here. I think for this we'll actually define a default of a brush with a default size of 2. So then if we take these out, yeah, so we still get our nice terrain generation. Okay, so in this one, we define a brush, and then we're going to get a context, and then for X in 0 to width, and for Y in 0 to sorry, it's context at width. This is actually a pretty terrible way of drawing the frame, actually. So for X in width, what we want to do is zero to size. No. Yeah, so we got offset by the width divided, and for each of the X, we're going to go context of draw X offset brush, and then context of draw the height minus the offset plus 1, sorry, minus 1. Yes, that should also draw. So that should draw the 2 lines across the top, and then we want to draw 2 lines down the side. So this will be a mirror of that, and we want offset and width minus offset, and we want Y as the other parameter. There, and then this all goes away. Yeah, and if we draw a brush of size 2, it doesn't render. So why is that? Because the defaults, we want to set the brush to be a wall. There we go. Yeah. Okay. No. So we the extra -1 on the edge here is unnecessary. Okay. but we need to make sure the rounding works correctly. So 02 equals brush size minus that. Oh, and that's indented ever slightly wrong. Okay, so that works for 2. What if we give it an odd number though? It still works. And for 3, it still works. And I think that is the default we want for our frame, right? For our filled one, this one's a bit more. So this will be context. We define a brush, and then for X and for Y. For 0 to the context.width, and for 0 to the context.height, then we're going to draw onto the context with the value, and that will give us our field one back. Then we can go for the same for the cellular automata. We can okay, so if we add in yes, we want to take the current maybe we want a new method on our context. Oh. Def copy, and this will return a this will return a new context, same as we have here. But we're going to take a deep copy of the data. So if we come down to our cellular automator, then we go, so we're going to copy the context, and then for a range of, see, this was also not necessarily legit in how it was implemented either. So for range of 0 to context.width, yeah, so tidying this up is basically just giving us a has given us a sort of setup that's a bit more that's a bit more easy to spot some of the bugs that we would have otherwise hit. So we're also going to want 2 brushes. Oh, sorry, no, it was value of size equals 1. So we're going to create 2 brushes, one for dead and one for alive, and we're going to go context.draw with the dead brush, and then context.draw with the live brush. I think that's a bit nicer because it sort of lines up a bit more. But yeah, okay, so then if we run the cellular automata, I got size. Yeah, this is to do with the Crunker's walk generation. Here we go. So now we've got our cellular automata running on our new context as well. Yeah, I think at the 2x2 this is actually generating far more interesting structures. Okay, now for the room based. So again, this is context. The room generation also takes the context now instead. We'll take a subcontext for each room. how do we define the tunnels? Tunnel generator. Oh, sorry about that. The tunnel generator, we said we'll take the context. It doesn't need. Okay. So we should pass the context in first, then the X and Y positions. And then we probably want to pass it a brush. Oh, sorry. Okay. Yeah, so given that when we come back down to our room-based generator, we're going to want to pass a context in here, and then we're going to want to pass a brush for this. We could probably actually leave the brush out and use the default for now. That stays the same. That stays the same. Actually, yes, so sorry, so the tunnel generator, we had, yeah, this is just X and Y, the context, no brush defined, and then when we come to our tunnel generator, we'll take a brush as a parameter. So take a context. We can take this out completely. We use a random number generator on the context, and then context.draw. The X and Y, and then we'll pass it in the brush straight through. And this we will default to a size 3 brush. Oh. So, yeah, that, and then this is the brush. So now we have a simple tunnel generator, and then our simple room generator is, again, we will go context. And then the context in there. This is from we'll just go from 0 to context or width, context or height minus h. We can take the edge protection out of this for now, I think. Yeah, we make sure there's no overlap, and then we append the value, and then when we run this, what do we get? We get an error in as and this is in the tunnel generator. Let's make sure all of our previous cells are run. We should probably try and make sure that we're using the labeled parameters here as well, so that we can actually see what things mean. Min width, min height, max width and max height. Here we go. So now, okay, so our random placement is working. We should also potentially, we have a concept of spacing in the BSP generator, so we should potentially add that in here. Yeah, and I think that is where we will okay, so we generate a space size between width and height, and then we go from use spacing to take ourselves away from the wall. And then we we want to make sure that it's not too big. So we want to make sure that the room is the width and the height of the room will actually fit into the space. Otherwise, this will fail because we'll end up with a value less than spacing. So effectively, we just rearrange this as these parameters to ensure that this side will always be bigger than this side. So our from, when we generate a random integer, the from value will always be smaller than smaller or equal to the destination value. The total, the upper value. Okay, let's put the spacing on the end there so it's not set, and then if we run this again, should ensure that the rooms stay spread out a bit. Yeah, they're not getting right up against each other anymore from the looks of it. So give it a few runs just to make sure. And haven't seen any touching yet. Then again, it could just be luck of the draw, but yeah, I think we have the spacing concept now in that one as well. Okay, so now BSP1. This can be context again. This will take the context on it. So I think we can prefix the values that are now in the context. And the same here, we'll make sure that these values are all prefixed. Interesting. So where is that failing? Okay, so it's the nodes that were the issue. So this actually becomes a bit simpler, I think. So we have spacing, width minus 2 times the spacing, and the height minus 2 times the spacing. another error. So somewhere in here I messed up the RNG. Here we go. Okay, so this should be RNG. Okay, and then now we have our binary space partitioning working. Although there are some peculiarities here. So one thing we could do to help visualize this would be to draw in our spaces into another canvas and render that. So yeah, so that should generate us a data array, and then we should be able to go. Actually, we copy the context and we go generate fill. So I want to visualize I want to quickly visualize how the binary space partitioning is working. So generate fill, and then we pass in a new subcontext on each of those, and then afterwards, before we return the results, we call render data with the data. Binary and PSP regions. So then when we run this, we should get as a extra Oh, this is why, because we didn't set this in. Okay, so we should be able to see how the structure is. It's divvied up now. So as it should get darker following the way in which the rooms are added. Sorry. And therefore they should be joined in that order as well. Here So this one is drawing a line all the way over to this one from the looks of it. So I think we can see here it's been maybe divided that way, then split again. That has been split there and then there. I think so now when we look, so the connection will flow from there to there to there, but then potentially that way. Which is not the angle we sort of want. So we kind of want these to connect always to a neighboring cell. Maybe this is just me misunderstanding the binary space partitioning algorithm, but my thinking was that we would be able to get more of a link between things. Let's also, we've got some weird values for this one in our setup. Rooms equals spacing equals ratio max steps and BSP count. Let's put the spacing back as 1. Yeah, we're getting some interest. Okay, so we've got these rendering a bit smarter now. Yeah, I think when we generate these, we probably want to change the values up a bit. I've just realised we've nearly done 2 hours now. We haven't actually made any real changes to how added any new algorithms to our code. We have tidied it up a fair bit though. let's take the BSP regions back out. Where is that? That was in here, wasn't it? So we can take all of this out. Give it a run. Yeah. Okay. So we have improved some of this. We've not actually added anything new to our toolbox though. So I was only hoping to do a 2-hour stream today, but let's look at the symmetry. So this is why we plumbed all of this stuff in. So now if we have a dyslexia strikes again. How do we spell symmetry? Let's just copy paste it from before. Here we go, brush. So we're going to have symmetry. And we're going to have none, horizontal, vertical, or both. I guess different types of symmetry we can also have rotational. Not 100% sure if we want to look at rotational symmetry yet, but we can definitely look at adding it later. So when we draw, this is where this will come in. So as we draw, we will update things, and if we have horizontal or both for the symmetry, we will look at hang on. Yeah. So if we make it this far, we'll go if self.data minus ix. Oh, hang on, minus I. No, I've done this the wrong way around. So then we want self.y plus self.width minus y is not equal to that. Then we increase the result. Then we set it to a value. So, I think actually we'll go. We'll set these to we'll set an nx and ny. So our new x and new y will be effectively the inverse. actually. No, wait, this is wrong. Yes, the y will stay the same. The I will stay the same, the x will flip, so that we are, for every time we draw on one side, we draw on the other side as well. And then we're going to have vertical. And for vertical symmetry, we have a we're going to have the opposite, and we're going to do the we're going to have the new y is set instead. And then if it is both, then we also want to do new x and new y. Actually, so we can actually let's calculate these outside of the if statement. So we want new x and so this will be, actually let's go for mirror x and mirror y. So now we update the values in the inverse coordinates. As well. So with that change, with the changes we've already made and that change, then if we now come and have a look at, say, our drunken walk, we could set a new drunkard's walk. And for our symmetry, we can set horizontal. Sorry. So then when we set a horizontal symmetry, oh, did I not run all of the above changes? So yeah, oh. That actually looks kind of scary. It's like some sort of weird skull, right? Horns coming out of it. But we can get some interesting shapes out of it. So let's have another one with vertical, and then we'll do both as well. So then if we run this, I mean, some of these, okay, that's a bit, that one's gone a bit squiff. The horizontal ones, so some of these are not working 100%. bug in our mirroring code. So if we make a, I don't think that was it, but if we then, so the horizontal symmetry seems to be working fine. It's the vertical that is going a bit weird. Okay, so are we transposing any coordinates here? It's normally the first. Yes, we are. So horizontal is working right, and then yes, this should be IX. Okay, so now if we go find oh, okay. So we're getting some quite interesting shapes by adding symmetry into this. If we tune the number of steps, so by turning down the number of steps, we should start to get more. Yeah, so the shapes that we get out of this are now becoming a bit more sort of cavernous. But with a bit of tuning, we could probably get some nice sort of round, interesting round caverns. Something like that. So this is actually giving us some. Yeah, I think with when we do the when we do some of the other brushes, I think will also have some interesting effects coming out of the symmetry brush, the brush symmetry as well. Let's set these back to 2000, or even 4000. Actually, the 40,000 is probably going to generate some interesting effects with the symmetry as well, because it's going to wander a bit further and a bit more chaotically. So yeah, we get some really interesting. really interesting patterns here. Some of the mirrored ones would make an interesting sort of. They would make for some sort of interesting terrain, I guess. But if we applied multiple passes with different generators. Oh wow, that is yeah, I think some of these are quite pretty, but I'm not so sure if they're the best for the dungeon generation. Although as I say that, then we land on something like this, which would actually be a pretty interesting field, I think. So I think there's some. So okay, so I think there's something in the symmetry for the Drunkard's Walk, but I mentioned earlier that we have the diffusion limited aggregation, which is a different kind of random walk to the Drunkard's Walk, which I think would actually generate a more interesting pattern with the symmetry. Just out of interest, what kind of cursed things would we get if we applied the symmetry to our random placement? So if we take this and set symmetry to both. I mean, it's with the symmetry. This is actually kind of approximating in on something usable. And that's an interesting shape, right? We could probably do something with that. Let's actually take this out of this section. Let's take it down to our combined section. See if we can get something interesting. Okay, so if we chain on some values. We run it through cellular automata. Okay. Let's maybe reduce the ratio down a bit first. Frame it out actually. Too many commas there. And this is not too bad. What if we increase the size of the brush? we decrease the size of the brush? This isn't bad. Like if we were actually to do some sort of culling of the unreachable areas, so take all this out, these little bits, this middle section, we'd almost have, well no, we would have a playable level here, right? Oh, that would be quite cool. So I think there's something in this, but we would need so what is this? This is oh. This is large with cellular produces can produce interesting cavern-like maps, because I think that's what that is. I think this is like this is more of a cavern style. This is sort of a roomy sort of interconnected caves, whereas this is more of just one giant cave that's carved out. Yeah, I think we. I think so. That time, I think we didn't get a playable map, but for the most part we are. And I guess any map generator we build will effectively just have to generate and discard. So if we hit a unworkable seed, it will have to fathom its way through that. Yeah, this one again, quite a large area. Okay, I think next week we will probably look at maybe a flood fill based discarding of the unreachable areas. So I kind of want to see what this would look like without those. I might have a little look at that before next week if I have time. Random placement, size equals 3 and symmetry equals both plus cellular automat. Yeah, because this is generating some quite interesting shapes. Flood fill is something I still need to do a bit more reading on. It's like I get in theory how a flood fill algorithm helps and how we would find the unreachable areas. The bit that I'm currently struggling on, that I haven't actually fully wrapped my head around, is how we find the largest area, or we find all distinct regions. But that is something we can look at in a future episode. I'm thinking we could in theory just flood fill every empty region we find until we find, and keep going, and then add all of the cells that we find into sets, and then we take the largest set and we fill in the remaining sets with walls. That'll give us our largest continuous area. Or we could even once we have those sets, we could also have an algorithm where we sort of try and interconnect the larger sets. We interconnect the larger sets and then discard any sets under a certain size. So we maybe keep. Let's find. That would be an interesting cave level. Yeah, actually, this is producing some really good, nice results, which is weird because this was not a combination of. This was not on my list of things that would actually be worth investing time and effort in and like looking at, but it's actually doing a pretty good job. I guess it's the cellular automata is doing the heavy lifting, but by having a more clumpy sort of base for it, I think it's actually generating a more connected sort of area than it was if we look at the cellular automata on its own, for instance, just on a randomized plane. Like we've got a lot of disconnected areas here, but by making more blocky, we end up with more interconnection. But even so, I think this is actually not a bad. I think we're getting some pretty good interconnection here as well, though, just with the default star. It'll be interesting to see how both once we get flood fill working. It'd be interesting to see how both of them work out. I kind of want to have a. I want to have a look at a drunkard's walk with the as well, to see how that comes out with the symmetry and the cellular automata. So let's add markdown, add a code, and then we want a drunkard's walk. So let's add some symmetry in there. We probably want a longer walking distance. Oh. Okay, so for big caverns, this is actually not bad. This is giving us a space that's got quite a nice big sort of cavernous area to it. Like for a boss arena, I think some of these would be actually. I think these are actually pretty good. If we restrict the stagger distance, get more centralized, less windy. Yeah, these are quite nice. Something else we could do as well is if we take like a 25% and maybe give the drunkards quite a bit of a distance so they can stagger. 2%. Okay, and then we'll give them a sort of windy sort of off the. Okay, we can then actually take another drunkard's walk with and add incremental amount, and we should get. I mean, that's quite an interesting cavern, right? So we've now sort of layering the drunkard's walks on top of each other. I think that's actually giving some quite interesting results as well. I think we'll go back to what we had initially though. We'll put a let's find a good value. But this, yeah, so drunkard's walk, a symmetrical drunkard's walk also produces some pretty good values, and then we can so I think we'll go with, I think we might so I think this one is mine was automated a nice yeah, so we get a nice sort of central cavern in these ones, I think, and then especially when we dial down the distance the drunkards can walk. So we go to 2. Where do we go to 1,000? Yeah, so something like that's, we're getting into just a nice sort of, not, we're getting into the realms of almost circular, but not. generation. So yeah, this is how we can. I think this is a good way for us to sort of look at generating. I think there's something in this one, and we can probably in the Drunkard's Walk, the symmetrical Drunkard's Walk, and the with the cellular automata, sorry, we can get a. I think we're getting towards something we can use for boss arenas. The random placement with the cellular automata, we're getting towards somewhere we can get sort of quite a cavey sort of experience. And I think with the BSP and the random walk and the cellular automata, we're getting towards some sort of interconnected caverns, interconnected caves, different rooms, style dungeon. By swapping the Drunkard's Walk out in this and removing the cellular automata, we'll get towards something more of a traditional sort of more man-made dungeon style dungeon, and yeah, I think if we crank this one up, we can get more to we can and start to look at actual biome generation. We could get towards sort of a forest level as well and stuff like that. But I feel like our toolkit is, although we barely added any code this time, we just added the symmetry. I feel like our toolkit is already expanding, and we're getting closer to being able to generate our ideal terrain. I think what we'll end up with in the final game will be we'll sort of hand tune some of these combos, plus combos we probably haven't even looked at yet, and we'll hand tune them to get some good sort of styles and then for each style we'll have each style, and then we'll pick a style at random for each level of the dungeon. So as you're moving down, you'll pass through like cavernous levels, winding cave, networks of interconnected caves, man-made sort of tunnels and rooms, maybe some like if we use the BSP and if we tweak the BSP slightly so we can get the rooms out without the random generation within them. Actually, that is a thought. So I think we need to probably tweak the BSP room and be able to chain some of the rooms, so that we can potentially tweak them a bit more. We could probably get a nice little castle interior. Lots of sort of rooms that butt up next to each other with thin walls between them. That would be pretty cool. Yeah, okay, but I feel like we're getting a bit closer. As I said, we didn't clear much of our list today, but we did at least clear off the symmetry. I think I will have a look at. I'll try and read a few more papers as well on this week on the because I need to have a look at some paper. I need to have a read through the paper, some of the papers on the Delaney triangulation algorithms. And once we have that, what the algorithm is in essence is given some rooms. Given some rooms, it will calculate the non-overlapping routes between them. So for instance, we'll get like a line here, and then to this one. So these will all connect up without sort of crossing over the lines between each other. Potentially this one as well. But yeah, but this one and this one will not be able to connect because it will cross. If we're trying to draw a line from this one to this one, we'll cross the line between these two. So it sort of figures out a network of connections between the rooms that don't overlap, and then we can effectively, once we've got that, we can print it back. So there is the minimal spanning path, which will give us the shortest sort of route through that will pass through every room. And then we can also do some other stuff with some different maze algorithms to interconnect them. So I think that's a future, something for us to look at in the future. So I think next time we'll probably look at room. Next week we'll either look at diffusion limited aggregation, or we'll have a look at more room generation and edge generation techniques. But I think that is all for today, and if you've liked the video, give it a like. If you want to see where we're heading with this, then hit the subscribe button, and I will be back next week with some more game dev and some more game dev algorithms. I'm going to try and post these up. I'll post the notebook up as well, so that it will be accessible and available for poking at as well. But until next week, goodbye, and hopefully I will see you in the next one.